Alright guys, today we're going to look at the review problems that we had up in class, so hopefully you have those on you and have tried them / done them all already. This will just be a quick walkthrough and some answers to each of those. So the first one was the square root of 32. If you're doing this with a factor tree, you just want to make a factor tree and make sure that you group them in pairs, right? Because we want to figure out all the perfect squares is what we're trying to create. So rather than writing this as 2 to the 5th, I'm going to write it as 2 squared times 2 squared times 2. And I'm going to put that back inside my root. Okay, so then taking the square root of 2 squared gets me 2 for both of those, and the one that doesn't have a squared stays in, okay? So that one stays in, these other two turn into my little individual 2's there, and I get 4 times the square root of 2. Okay, that's it for the first one. The second one here is 2 square root of 3 times 3 square root of 21. You can multiply the numbers that are outside the root and the numbers that are inside the root. So I get 6 square root 63. Now I'm not done. I need to make a factor tree for 63 or use perfect squares, whatever you use. So I can write this number as 3 squared times 7. And I'm going to put the numbers in the square root in red so we can kind of keep track of where those were coming from. Now the square root of 3 squared is 3, and the 7 needs to stay inside the square root. So that 3 squared turned into a 3, and the 7 stayed inside because it wasn't a perfect square. Multiply the 6 and the 3, and we get 18 square root 7. Okay, number 3, this one's more just a little bit annoying. You can simply add the numbers together. It's very similar to adding variables together. You have to have the same number underneath the square root to do that. But you can simplify each of these square roots. Okay, so we're going to do that first. So I'm not going to physically write out the factor tree. I'm just going to show you the result of it if I was using perfect squares method. Okay, I'm going to write all the original stuff in red so we can kind of keep track of that. I'll show my factor trees in black. 8 I would write as 2 squared times 2. 27 is 3 squared times 3. And 32 as 2 squared, and 2. Okay, so then in this first one, the 2 squared gets to come out. It's a perfect square. The other 2 is stuck in. Oops. In the second one, the 1, 3 stays in. Oops, wrong color. I want to use black for that. 1, 3 stays in, and the other 3 gets to come out. And then here, 2 2's get to come out because they have squareds attached to them and the other 2 stays in. So now I get 4 square root 2 plus 12 square root 3 plus 12 square root 2. These are my like terms, so I get to add those together, and I get 16 square root of 2 when I add those, and 12 square root of 3 has to stay separate. Okay, so you can only add them if they've got the same number under the square root. All right, number 4 is 4 over the square root of 200. Okay, I'm gonna move through my work a little quicker this time. So multiply by square root of 200 on top and bottom. You didn't have to start off this way, but I just like to get rid of it to begin with. It seems easier to me. Now I'm going to simplify that square root of 200, and this time I'm going to use perfect squares method for those that use the perfect squares method so they can see that. I'm going to rewrite that as 100 times 2. The square root of 100 is 10. So that gets to come out. The 2 stays in. 4 times 10 is 40. And then the 400 over the 200 simplifies to 1 over 5. But, as you guys know, we don't need to write the 1. So I get square root of 2 over 5. Let's get those equations in here. The hardest one actually came first. The first thing you need to do in this one is get the square root by itself by adding 1 to both sides. Then we need to square both sides. On the left side, that just means square root's going to cancel out. On the right side, that means we're multiplying x plus 1 times itself. When we do that and combine like terms, we get x squared plus 2x plus 1. That comes from multiplying out and combining like terms. Okay, now we need to use quadratic formula. You can't use quadratic formula unless your equation's equal to 0, so subtract 4x and 4 over to the other side. We get 0 equals x squared minus 2x minus 3. I'm going to use quadratic formula with my a1, my b negative 2, and my c negative 3. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so negative b, that's going to be just a positive 2 because the 2 negatives cancel out. Then I get negative 2 squared minus 4 times 1 times negative 3 all over 2 times 1. Simplify. I get the square root of 4 plus 12. The key is that double negative over there turns into a positive. So I get 2 plus or minus square root of 16 over 2. The square root of 16 is 4. So I get 2 plus 4 over 2 and 2 minus 4 over 2. That gives me answers of 6 over 2, which is 3, and negative 2 over 2, which is negative 1. You should plug both of these numbers back in for x and check to make sure they work. This is a very rare case in which both answers work. The 3 gets you the square root of 16 minus 1, which is 3, so that works. And the other one gets you the square root of 0 minus 1, which is negative 1. So both of these definitely work. Next one's much easier. Okay, now that last one that we did, there's going to be one like that on there, but it will be extra credit. This one will not be, though. Got to be able to do this one. So we don't have to get the square root by itself. We just need to square both sides right away. No need to use the quadratic formula here, guys, because there's no x squared. Just solve for x like you normally would by subtracting, my fault, 1 from both sides and dividing by 2. You should check this answer too, but this answer also works. Okay, last two triangles. I've got a triangle with sides 6 and 8, and I've got a triangle with sides 10 and 24. Okay, so in this one, you're missing the C, and you have A and B. And you use the Pythagorean theorem. Plug in for A and B. Square those numbers. Add them together. And then take the square root of both sides. We get that C is 10. And then over here, the only real difference that we have here is that we are given C and B and not A. So when I write out our formula, that's going to leave me with a little bit of work. So I get A squared plus 100 equals 576. Subtract 100 from both sides, so we can just get A squared by itself, and we get that A squared is 476. Take the square root of 476, and we get 21.8. So A is 21.8. Okay, that was a quick walkthrough of all those different problems. If you had problems with each of those individually, I'm here tomorrow morning, so stop in and we can get any last minute problems corrected.